So we are on the integrating factor method. Basically, is still a way of solving basically ODEs, ordinary differential equation, and it solves equations of this form, an equation of this form. If you remember very well, when we were going through integration, there are so many techniques of integration. There was substitution, completing the square, partial fractions, integration by parts, and basically you had to gauge the problem and see which technique you will be able to apply. So the same way, if you know how the equation looks like, then you can either be able to apply either what we learned, separation of variables, uh, exact differential equations, homogeneous differential equation, as long as you can be able to put it in a form that we have been able to describe. So in the integrating factor method, basically, we integrate, we use it basically to integrate equations of this form by introducing an integrating factor. The integrating factor, I'll call it IF, integrating factor IF. What we normally do, introduce the integrating factor, exponential P dx. So normally, the integrating factor, we introduce an exponential, it will always be given by exponential, and then we integrate the P. The P is next to the Y. The P is always next to the Y. You can be able to see the P is always next to the Y. The P is always next to the Y. And you have to make sure that the dy dx here, this one here, is of coefficient 1. You have to make sure it is coefficient 1. So if there's anything there, you divide so that you have an equation of this form. Then you have integrate P in terms of what? In terms of X. When you integrate P in terms of X, this one here, don't add a constant of integration first. Don't add a constant of integration. I'll show you why. We don't add a constant of integration. You just integrate and you don't add a constant of integration. So very important. So integrate the P, you'll get exponential that integration P dx, and then you don't add a what? You don't add a C, basically, a constant of integration. After you do that, you take the integrating factor and you multiply with the whole of the equation. So this is the equation that I have. The equation that I have, dy 1 over dx plus P, Py. We had Py,
Excuse me, sir.
Yes.
Can you refresh your board, please? I'm not seeing.
Resume recording. You don't add a constant of integration. So I was basically back to my equation, repeating the equation the way it was. This was y is equals to what? To q. Now the integrating factor here, the one that I've introduced, I'll multiply with the whole of this equation here. We are still on the theory bit, bear with me. So I'll multiply here with the what? With the integrating factor. Like that. P dx. So I multiply everything with P dx. So if I multiply with P dx, the first one I'll have is exponential P dx, and then dy dx, and then here I'll have exponential P dx, and then Py, and then here I'll have exponential P dx, and then q. So you multiply everything with the integrating factor. Remember, when you do an example, it will not be like this, it will be much better. So now the final answer now for these two now, we combine these two. We combine these two. So what we normally do, this one, the final solution for this one, this side on the right hand side, we normally integrate the normal way. But now on the left hand side, the combination of these two, we normally pick under dy dx, we pick the exponential p dx. And then on this other side, we pick basically only the y. Don't worry, I'll show you an example. And on this other side, we just integrate the normal way we integrate this side. P dx and then q. So very important. On this side, we shall only be picking. There's a step I've jumped, but I'll be able to show you. We normally just pick the function that is next to dy dx, and on this side we just pick only the y, and then on this side we just integrate. I'm making work easier for you. And when you integrate, you'll be able to get an answer. I think now I can be able to do one example to demonstrate this now. Then you will be able to say if we are following. Let's just do an example. Number one. Let's integrate this one. Let's solve this equation using the integrating factor method. That one there. So we solve that one, number one. So we have said, for us to be able to solve this equation, we have said the coefficient of dy dx has to be of number 1. Has to be of number 1. So I'll need to manipulate this equation. I'll have to divide all through by x so that at least the coefficient of dy dx is number 1. So I'll have what? Dy all over dx plus 2 over x y is equals to 4 x squared all over x. I'll divide it throughout by x because I want a coefficient of 1. It's still the same equation. Then I simplify this one. I have dy all over dx plus 2 over xy is equals to 4x. And you can be able to see this equation is of the form that I had given. Remember the equation that I had given? Dy all over dx plus py is equals to q. So basically, if you check those ones, that is basically what I wanted. I wanted the coefficient of dy dx to be 1. That's why I've divided throughout by what? By x, to have that, to have what I have. So you divide first of all by x throughout, and you'll be able to have that. Now I'll introduce the integrating factor. We have said, where do we introduce the integrating factor? I'll introduce the integrating factor basically on the p. So what is my p there? My p from the equation, if I can be able to do a direct correspondent, my p is what? 2 over x. So the integrating factor will be given by exponential. I integrate 2 over x. That is my what? That is my p dx. I integrate 2 over x dx. So I can be able to do it here outside the power, so at least we see what we are getting. So 2 over x dx, when you integrate, I believe we'll be able to get what here? 2 ln x. When you integrate that one, I'm getting 2 ln x. When you get 2 ln x, you need to manipulate this one. I'll use law number 3 of logarithms. This power can be able to come. I'll show you why later I do like that. So this power is the same as ln x squared, law number 3 of logs. When you have a constant before, it can come to the power, or when you have a power, it can be able to come in front. So it's the same as that. So instead of having all that, I'll have exponential ln x squared. Exponential ln x squared. So this one, I hope someone has a calc. I think they'll be able to assist me here, but we have done this one before. So ln and exponential, they have, Oscar's gotten it. So they have a special relationship. If you use a calc and get exponential ln 2, you get what? 2. Exponential ln 3 using a calculator, you get what? 3. So exponential ln x squared, you should be able to get what? X squared. You can be able to see the pattern. You are remaining with the value that is here, the one that I'm circling. It's simple as that. So you get x squared. And that's the reason why I was bringing these two. Let me use a different mark, the green one. So that's why I was bringing the two this side here. so that at least we end up with only a ln. Like this, it cannot be able to work. 2 ln x cannot be able to work. So you must be able to have just exponential ln, not exponential constant first, just exponential ln. So you have to use law number 3 there of logarithms. And remember the relationship between exponential and ln. Exponential and ln. If you don't remember that relationship, it will be hard. It will be hard for you to be able to do it. So can we continue now? So from there, my integrating factor, I've gotten it as x squared after simplification. I will multiply through the equation with this one. So what was my equation? I come back up here. The equation that I had done, I had dy dx plus 2 over x. I repeat again that equation there. Dy over dx. I repeat the equation dy all over dx. This is what I had. Plus 2 all over xy is equals to 4x. Remember, I divided by x. So the whole of this one, I'll multiply the integrating factor. The integrating factor, after we have simplified, was given by x squared. So I multiply. So the first one, what I'll get if I multiply, I'll get x squared dy dx plus, the other example, I'll jump some step because this one I can easily simplify. Y is equals to 4x times x squared. Let me open up and see what I'm getting. So I'm getting x squared dy dx plus, when you simplify this one, you get 2x y. This one you get what? 4x to power 3. Now I said what now? On the left hand side, on these two, I'll just combine. So here is simple, no calculation at all. Here, this what I'm marking in red. I said for the dy dx, you just take the function that is in front of it, this side. So I'll just take the x squared like that. On the side of y, on the side of 2xy, you just pick the y. You just pick the y. So I'm picking this one, the one I'm scribbling in red, and this one only, and the y. Then on this other side, I integrate 4x to power 3, and I'm done. So this side you pick x squared, where you have dy dx, the function that is in front of it. This other side you only pick the y. The constant, the x, you don't pick it. The 2x, you don't pick it. You just pick the y. And on the right hand side now you integrate. You just integrate. Simple as that. Simple as that. Pick dy dx, the function x squared, and on this other side just pick the y. No x, no 2. And on this other side, the way the function is, but we integrate. So when you integrate this function, what will you get? So this side will remain the way it is. We had already picked this one. So you'll get 4x raised to power 4 all over 4. Then you can be able now to add on the final answer the constant of integration now. And the final answer will be x squared y is equals to x to power 4 plus c. And we are done with that one. So again, I'll repeat. On the left-hand side, you pick the function that is next to dy dx, and on this side, you only pick the y. On the right-hand side, we just integrate. The normal way you integrate a function, and that is the final answer for that one. So I hope it wasn't that hard for you. Let me do another one. Let me do another one. Number 2. Take this one out. Dy all over dx minus 3y is equals to exponential 4x, like that. Now this one already, it is in the form of dy dx. It is of this form. So there's no need of dividing with anything. It's given by what? P y is equals to q. So you can be able to see the coefficient of dy dx is number 1. So you don't need to be able to, you don't need to be able to simplify anything. So already is in form. So I'll come and take now just the integrating factor. So I'll have exponential. So I'll ask a question. What is my p? Can someone see what is my P? Can you do a direct correspondence with that equation? What is my P? Can someone do that one? What do you think is my P there? What is my P?
-3.
Yes, very important. -3. No. Look of it, we said the P is next to Y, so it cannot be -3Y. If you do a direct correspondence, it shall be -3, not -3Y. No Y. So it's very important. There's a negative, so we shall pick the negative. So let's pick the negative. So we shall now integrate -3. We integrate always in terms of x. Now this one is easy to integrate -3 dx. I want to do the power also so that at least you can be able to see what you get. So integrate dx, will get here negative what? -3x. Please don't add a constant of integration, you'll be wrong. When the constant is not playing any part. So when you integrate dx, we always get x. You always get x. So instead of this one, we shall be able to have exponential -3x. Now, here there's no ln. There's no ln, and you'll give me the final answer to be -3x. No. When you have ln and exponential, then you can remain with whatever is after. But here there's no ln, so the integrating factor, it will remain the way it is. That's why I've done this example. So I'll take the integrating factor, then I multiply my equation with it. My equation was reading like this: dy all over dx minus 3y was given by what? Let me remember here. I go up, exponential 4x, exponential 4x, and then I multiply the whole of this one with the integrating factor, which we got it as -3x. So I'll multiply. So when I multiply, I'll get exponential -3x dy all over dx. Here I'll get -3 exponential -3x y. This one, I can be able to use laws of indices. They are under the same base. So I'll have exponential 4x minus 3x. I can be able to subtract, yes. They are under the same base. So you are allowed when you're multiplying. When you're multiplying under the same base, you can be able to add the power or subtract the power. So this is what I'll end up: -3x dy all over dx will be -3 exponential -3xy. Sorry, the y is supposed to come down. The y is supposed to come like that. When you add 4x, you'll get what? X, just x. Now, let's now deal with the left hand side. So the left hand side, we don't do any calculation. So we have said here, this side, the one I'm marking in green, we have said I'll take the function that is next to dy dx, which is the same as -3x, the way it is. And on this other side, I'll not take a constant, and I will not take anything that has x. I'll just take the y, just like that. Just take the y. This side you pick, on this other side you only pick the y. Now this other side we said what? We integrate now exponential x. We integrate exponential x. So when you integrate exponential x, what do you get? You get -3xy. When you integrate exponential x again, you'll just get exponential x plus c. If you want to make y the subject of the formula, you can still be able to make y the subject of the formula if you prefer. But an answer like that one, for me, it is still okay. If you want to make y the subject of the formula, you can divide both sides by exponential -3x. Some books do like that. You divide here by -3x like that, and then here -3x, and then here -3x. If you want to make y the subject, so you'll get y will be given by. So you can be able to use some laws of indices here. So we remain with what? X minus minus will remain with 4x. When a negative power will go up, it will become positive. So it will remain with 3x. So you can either have the two. I don't have a problem with it. The first one, or in some other books, they make y the side of the formula by dividing. That's the first answer in red. or you can be able to have this answer. But you can be able to see the second answer is much prettier than the first one. So let me do another one still. Do another one. It is simple as that. Number 3. Number 3. X dy dx plus 5y is equals to ln x all over x. Can be able to do that one. So again, you can be able to see this equation is not of the form of this one. So we must be able to make it at least the constant of dy dx to be number 1. So what do? I divide throughout by x. I divide throughout by x. If I divide throughout by x, this is what I'll be able to get. Sorry, 5 over x y, and then ln x all over x squared. So I've divided throughout by x. So remember on the right hand side where I have ln x over x, if I divide by x, I'll have x squared. So you must be able to put it in this form. Check again, you must be able to put it in that form. I've divided throughout by x. So I'll take my integrating factor. My integrating factor will be given by exponential 5 over x. I integrate that one, dx. You can be able to see my integrating factor here is 5 over x. If I had just taken the way it was before on the equation, I'll have a different integrating factor. Here it is 5, which is wrong. So if you divide the root by x, you have a different function. Let me integrate this one again here, 5 over x. This one you'll get 5 ln x. But in the previous example, we need to bring this 5 using law number 3. That is ln x raised to power 5. So very important to use law number 3. So the integrating factor here will be given by exponential ln x raised to 5. But again, we have seen there's a relationship. There's a relationship between exponential and ln. So here you remain with x raised to power 5. You remain basically with the function or with the constant. So I'll multiply the integrating factor with the whole of the equation and see what we are getting. So I'll get here dy, this is what I had, plus 5 all over xy is equals to ln x all over x squared. So the whole of this one, I multiply with x raised to power 5. Let me see what I'm getting. If I multiply that one, I'll get x to power 5 dy all over dx. Then if you multiply this one, you remain with 5 x raised to power 4y. I've cancelled one of the x with that one, and here you'll get what? X over 5 all over x squared, you remain with what? X raised to power 3 ln x. Remain with x to power 3 ln x when you cancel. Now, when you come to the left-hand side, let me use a different mark. What did we say? When you come to the left-hand side, you just pick the function that is next to dy dx, which is the same as x raised to power 5. And then here, you just pick the y. You don't pick the 5, you don't pick x to power 4, you only pick the y. And then you come and integrate the right-hand side, x to power 3 ln x. So I've forgotten the dx, so integrating always in terms of x. So class, I think the left-hand side doesn't have a problem because we are just picking, but the right-hand side one by integration by parts. So at least someone can be able to remember. So integration by parts. So Liate will work. Nice. That's good. So Liate will work for this function because we have a product. We are multiplying two things. So let's do this one, Liate. So we have ln and algebraic. So we want to see which one will be du, which one will, so we have Liate like that. Liate. So our function algebraic is there. And then we have the logarithm is here. Then going down, This one takes the u. Going upwards is take the dv. So the logarithm will take the u because it is up. So we shall let u be what? U to be what? To be x to power 3. No, sorry, ln x. Sorry for that. And then the dv shall be x to power 3, whatever that is remaining dx. So someone to differentiate for me here, du dx, what do you get? When you differentiate ln x, you get 1 over x. This one we integrate, remember? When you integrate this one, you'll get x to power 4 all over 4. Please don't add a constant of integration. So by parts says that v du is always given by what? uv minus v du. So kindly mute your mics. Kindly mute your mics. No, I think I've written it wrongly. It's not like that. That is not the correct. This one is not the correct. So pens, that one was wrong. I think it says what? Let me see. UDV. UDV, yes, it is written like that. UDV is equals to UV minus VDU. So let's put whatever that is there. So what is my U? My U, I had given it as ln x. I'm able to see my U is ln x. My U, I should not even be doing this one, ln x. And then my V is x to power 4, x to power 4 all over 4, minus my V is x to power 4 all over 4, and then my du. So if you make this on the side of the formula, the du will be given by 1 over x dx. 1 over x dx, 1 over x dx, if you make it the nini. So I can be able to cancel that one. Cancel that one. What do you remain? So this side we have already integrated. There's no need of manipulating. So this side, when you cancel, you remain with the integration of what? X to the power 3 all over 4. And then dx. So remember, 4 is not playing any part in the integration, and you'll be able to remove it outside. When I integrate x to power 3, I'll get x to power 4 over 4. So here I should be able to get, let me start with x to power 4 over 4, ln x. So I should be able to get x to power 4 all over 16, because it is 4 plus 4 integration. So I can be able to input now. This side I had x to power 5. Remember, I had x to power 5y. That's what I had. I had x to power 5y. If you want to make y the subject of the formula, this answer honestly is still okay with me. The most important thing is how to integrate this side here, the left-hand side. Very important. Sorry, the right-hand side. So if you want to make y the subject of the formula, you can divide throughout by x to power 5 if you want. So 4x to power 5 ln x minus x to power 4, 16x to power 5 plus c all over x to power 5 if you want. And you can be able to use some laws of indices to get an answer like this one. So you'll get here 1 all over 4x ln x minus 1 all over 16x. The power can be able to come up -5. It is still okay. If you want to make x the subject of the formula, you are still okay. So you must be good at integration if you want to do this one. If you want to do this one. So, anyone with a question so far? Let me remove this. So let me do another example. Your is number 4 now. So we have divide x plus 3x squared y is equals to x squared. So already this one is of the form of what we want. It is of the form of this one. Plus py is equals to q. So what we need to do is to pick our p, integrate the p. So the p here is 3x squared. So the integrating factor will be given by exponential 3x squared dx. When you integrate, please don't add a constant of integration. When you integrate 3x squared, what do you get? I believe you'll be able to get what? Add 1 to the power, divide by the new power, you should end up with x to power what? X to power 3. Please don't add a constant of integration. When you integrate 3x squared, add 1 to the power, and the 3 will cancel with the what? With the denominator. So I'm getting x to power 3, exponential x to power 3. So I'll take this exponential x to the equation, the one that I have. So this is what I have in the equation. I have dy all over dx plus 3x squared y is equals to x squared. I hope it's like that. X squared. I multiply the whole of this one with exponential x to power 3. Let me multiply each and every term. So you'll get exponential x to power 3 dy all over dx plus 3x squared exponential x to power 3 y is equals to x squared exponential x to power 3. So I multiplied each and every term. Okay. When we reach there, we said what? We said on the left hand side, we don't calculate, but we pick the function that is next to dy dx. And this side, we just pick the function that the y only, a function of y, not a function of constant, not a function of x. So you just pick this one. So I'm on this side. So I'll pick just the function that is next to dy dx, which is x to power 3. And on this side, I'll just pick the y. Then we said on the right hand side, we do what? To integrate x squared exponential x to power 3. We always integrate in terms of x. So my question will again arise to you. How do you integrate such? Because you have to be good at integration. How? So let's do this one. We have said we integrate by substitution, yes. So let's do this one. X squared exponential plus what? X to power 3. That's what we want to integrate in terms of x. So substitution will work. Substitution. So we shall let our u to be the power x to power 3. So here du dx shall be the same as 3x squared, which means that dx is the same as du all over 3x squared. So I replace everything and you'll be able to see it will be able to cancel. I'll have x squared and then exponential u and then du all over 3x squared. So I cancel that one and I cancel. So the 1 over 3 is not playing any part. So exponential u du. When you integrate exponential, you still get x1 exponential plus c. But what is my u? My u was x to the power 3. So I should end up with 1 over 3 exponential x to the power 3 plus c. So I substitute back what I had. I've integrated the right hand side. Let me check what I had. On the left hand side, I check what I have, and I've integrated this side. So I'll have what? Exponential x to the power 3y. So I want to plug everything. Exponential x to the power 3y. And after integrating this, what we are getting 1 over 3 exponential what? X to the power 3 plus c. That's what we are getting basically. Exponential like that. So if you want to make y the center of the formula, that answer is still okay with me. If you want to make y the center of the formula, you can still be able to do that by dividing throughout. So if I divide throughout, I remain here with y. I remain 1 over 3 exponential x to the power 3 all over x to the power 3 and then plus c all over exponential x to the power 3. And this one I can be able to simplify it as 1 over 3. When a positive power will come up, it will become negative. That's another way of writing it. That is still another way of writing it, or what we have here. Still, it doesn't work. But the problem is not even on the The problem is not even on how you'll be able to get the final answer. Are you good at integration? That's the question that we are asking. Are you good at integration, or have you forgotten the integration techniques? So, example, when you go, if you go, you can still be able to get the value of C if you have been given the what? The value of the boundary condition. So given the boundary condition, you can be able to get the value of what? There's some books you'll be able to see there are some boundary condition, giving that let's say for example, y of 0 is equals to 1. So basically the boundary condition will be able to assist you to get the value of the constant C. Y at 0 is equals to 1. So this one means what? So if you have given like such in a book, it means that y is equals to 1 when x is equals to 0. It means what? Y is equals to 1 when x is equals to 0. So you substitute back the value there. That's why we are making y the subject of the formula. It will be able to assist you to solve easily this one. So you substitute back here, you'll be able to get 1 is equals to 1 over 3 plus, we don't know the value of c, and then exponential negative 0 squared. So here you'll be able to get 1 plus, 1 is equals to 1 over 3 plus c. Any number raised to power 0, and you can be able to get the value of c. So here c will be what? C will be 2 over 3. So the boundary condition assists for you to be able to get the value of C. When you get the value of C, you replace back in the equation now. Instead of having the C here, check here now. Let me write with a different pen. Instead of having the C here, you'll have here 2 over 3 like that. Instead of having the C, you'll have 2 over 3. So remember the boundary condition you can be given. After you have solved everything, you just substitute back the value of x, the value of y, and then you'll be able to get the value of c if you prefer. Yes. Sawa. Anyone with a question now?